So we want to find here the second derivative of y with respect to x, which would be written like that. How would I get started? Take the first derivative. That's an excellent idea. What is the derivative of x to the 2/3? Okay, good. What is the derivative of y to the 2/3? Yeah, we just took the derivative of y with respect to x, so we need that dy dx in there. And that is equal to the derivative of 1, which is 0. Okay, cool. So then dy dx is going to equal, and I'm gonna do two steps in one here. I hope you guys can follow it. We'll subtract 2/3 x to the negative 1/3 to the other side. So we have negative x to the negative 1/3 over here. And then we're going to divide by 2/3 y to the negative 1/3. So we're going to have y to the negative 1/3 here. Why did I get rid of the 2/3? Yeah, they're going to cancel each other out when we divide, right? So we end up with that. I don't like that though. Anybody know why? I don't like the negative exponents. So let's do what? What do we do to get rid of those? Flip it, right? So what we really have is negative y to the 1/3 over x to the 1/3. And that's the first derivative. Good with that? Okay. So then, to find the second derivative, what do? We will use the quotient rule, yes. So there's our first derivative. To find the second derivative, we are going to use the quotient rule. So we have low d high. What is low? X to the 1/3. Derivative of the top. Derivative of negative y to the 1/3. Negative 1/3 y to the negative 2/3. Okay, that's low d high. And dy dx. Don't forget that, because we took the derivative of y's, right? Can you read that? Is that big enough? Okay. Minus high d low. Do we need parentheses? Probably. I mean, the negative and negative right next to each other, that might look bad. So negative y to the 1/3, right? D low. And do I need a dy dx or anything in there? Over the square of what's below. What's the square of x to the 1/3? Yeah, so x to the 1/3 squared is x to the 2/3. And we're done, right? No. We definitely should simplify at least some. We can actually simplify quite a bit. Let's look at a couple of things here as we go. We're going to have a fraction. What can I factor out of the top? What's in both of these terms here? A 1/3, right? And I'm going to factor the 1/3 out, but if I put a 1/3 out in front of a fraction, that's the same thing as putting what in the denominator? You guys knew that, right? So those 1/3s on top are going to become a 3 on the bottom. You guys okay with that? We do have some negative exponents there. I'm not sure what's going to happen with that, so I'll leave them there for a minute. But I've got the 1/3s gone. I'm going to cross those off, but I don't want to get rid of that negative. So get rid of that 3 and that 3 in the denominator. What can I do to simplify this first term here? The negative is going to go out front, right? I'm actually, well, I'm going to write that first term as a fraction. So on top of the fraction, I'm going to have x to the 1/3. And on the bottom of the fraction, I'm going to have y to the 2/3. And we're going to multiply that by dy dx, which is kind of like what might happen there. Then we have the negative and the negative are going to cancel each other out, and we're going to have a plus. On top, we're going to have what? Y to the 1/3, and on the bottom? I already took care of the negatives with this plus here. So it's just going to be x to the 2/3. Okay, that's not simplified, is it? No. So let's keep going. I need more space. Can you read that? You can at least read your own, right? Okay, now what? Haley, question?
Yeah, what happened to the x to the 2/3 is in the denominator?
What happened to... Oh, we might need that, won't we? Thanks. Thank you. Yes?
Didn't you cross simplify the two fractions already? But
Yes. So the x to the 1/3 and the x to the 1/3 are going to cancel each other out. Those are gone. Good. What else is going to cancel there?
Negative.
The negatives are going to cancel, and the y to the 1/3 with the y to the 2/3, and it's going to become a y to the 1/3, right? Okay, so in the first term there, we're going to have 1 over y to the 1/3 plus, how about the second term? Is anything going to simplify there? So we have y to the 1/3 over x to the 2/3, is that right? All over 3x to the 2/3. We still have a complex fraction here, and I don't like complex fractions because we have fractions within fractions. So what could we do to get rid of that? Cole?
remember, like the top fractions to like the cube root of y.
We could, but we would still have fractions there. We'll go ahead and leave. And actually, that might make it look cleaner, but since the original relation was given to us as an exponent rather than as a radical, we'll go ahead and leave it as an exponent. It wouldn't be wrong to do that, though. That would be okay. But what could we do to get rid of the fractions in the top? I'm hearing some mumbling. Multiply by y to the 1/3 and x to the 2/3, right? So if we multiply by y to the 1/3 and x to the 2/3, on top, we're going to get x to the 2/3 plus y to the 2/3, yep. And then on the bottom, we're going to get okay. I say that we're almost done, but there's one thing we can do that can simplify this quite a bit, and that would be what, Lewis? Oh.
Where did the dy dx go? Oh, it's
We substituted
okay.
this right here was dy dx. Good question. Yeah, the top is equal to what?
1.
Yeah. Remember from the original equation here, x to the 2/3 plus y to the 2/3 is 1. So the top here, the numerator, is really just equal to 1. So what we end up with then is 1 over 3x to the 4 thirds y to the 1/3.